Alright, so we're on 3.7, 1 to 1, and their inverses. So the last section here in chapter 3, so let's take a look.
I drank a lava lamp.
Alright, so 1 to 1 functions is saying that basically every input goes to exactly one output is what we're saying. Every x goes to one y. So, example 1. Prove that f of x is equals 3x plus 2 is 1 to 1. Here's how you prove something is 1 to 1. You take what you have, so 3x plus 2, and you set it equal to itself, but instead of a x, you put a y in there instead is the only difference. So it's 3x plus 2 equals 3y plus 2. So you solve them. If you get x equals y as your final answer, then it is a 1 to 1 function because you got x equals y. If you don't get x equals y, then it's not 1 to 1. So I minus 2 on both sides. When I do that, the 2's cancel out and the 2's cancel out there, giving me 3x equals 3y. Then I divide both sides by 3 because I'm trying to get the y by itself or the x by itself. It really doesn't matter, but you realize that both those cancel out, leaving you with x equals y. Since I got x equals y as my answer, I know that this is 1 to 1. So the answer is yes. However, here, x squared minus 3, so to figure out if it's 1 to 1, I do x squared minus 3 equals y squared minus 3. So, I first would try to get the x or the y by itself, so I'd add 3 to both sides, and when I do that, they cross out, give me x squared equals y squared. To get rid of this, I need to square root. But remember, whenever you square root one side, you end up getting plus or minus. So what this is saying is x equals y and x equals negative y. So I do get x equals y, but I also get x equals negative y, meaning that's why it's not 1 to 1, because I'm getting two answers. When I plug in x, I end up getting two answers for y.
Hey, does this soup make me look fat?
You could also do the horizontal line test. The graph is 1 to 1 if you draw a horizontal line and it crosses the graph at one point. So if you were to draw a horizontal line and it crosses it at one point, then it's 1 to 1.
What are you looking at?
So, horizontal line test to determine. There's 3x plus 2. That means I plot the point 2 because it's the y-intercept, up 3 over 1, up 3 over 1, and there's my line. So the horizontal line test states I draw a horizontal line through it. Okay, there's me drawing some horizontal lines through it. It's yes because it only crosses it at one point. Yes, it is 1 to 1. However, take a look at x squared minus 3. Well, remember, your points for x squared. You could just graph on the graphing calculator, but basically what this is saying is you move all your points down 3. So here's my points for x squared minus 3. It's not important on how to graph it. Right now, what's important is, do you realize if it's 1 to 1 or not? Just use your graphing calculator, honestly, to graph this. But there's the graph. When I draw a horizontal line through it, look how it's crossing it at 2 points. That's why this is not 1 to 1. So, inverse functions. It's when y equals f of x if and only if g equals, or x equals g of y. So the inverse function theorem states, and this is how you can tell if it's an inverse to the negative 1 power, g of f of x equals x, and f of g of y equals y. So basically, you take each of your inverses that you find and plug them back in. If you get x and y as your answer, then you have the inverses. Better to see with an example to see what we are actually doing here.
Lucky.
So, 3x minus 5, find the inverse. Here's what you do. Instead of it being f of x, you make it y. So, y equals 3x minus 5. Solve this problem for x. So, to solve for x, I'd add 5 to both sides. So, I get y plus 5 equals 3x. Then, divide by 3 on both sides. And I end up getting this as x. So, now I know what y equals. Now I know what x equals. So I have to take turns plugging stuff in. The order itself doesn't matter. I take all this, I plug it in for x and see what I get. I take all this, I plug that in down here for y, and I see what I get. That's what this means you're supposed to do. I don't care which one you do first, but you need to plug each one into each other and see what you get as your answers. So I'm going to plug in y first. So when I plug it in, I get 3x minus 5 plus 5 over 3. Well, minus 5 plus 5 cancels, leaving me with 3x over 3. The 3's cancel out, so I get x equals x. So far, so good. That's telling me that that's true, but I need to do it in reverse now. So now I need to plug all this in for x up here with this one. So I take all that and I plug that in. Well, a 3 on the outside and on the top and the bottom cancels out, leaving me with y plus 5 minus 5. Well, 5 minus 5, they cancel out, so I got y equals y. Because I got x equals x, because I got y equals y, I know for a fact, I proved that that's an inverse. You find an inverse just by doing this work up here to get the inverse, but this is the proof. This right here that I did is proving that that is the actual inverse of the problem. So we proved by getting x equals x and y equals y that those two items are inverses of each other.
So why don't you make like a tree and get out of here?
Alright, and we will continue when we come back with example 4 in our last section on one-to-one functions.